Method of infinite descent. Welcome back to our exploration of the method of infinite descent. In this video, we'll explore a fascinating application of this method by proving the irrationality of the square root of 2. So, let's dive right in. The square root of 2 is a famous irrational number, meaning it cannot be expressed as a fraction of two integers. Our goal is to prove this fact using the method of infinite descent. Proof by contradiction, irrationality of 2. Let's assume, for the sake of contradiction, that 2 is rational, which means it can be expressed as the ratio of two integers, p and q, in its simplest form with p and q being coprimes. Assume 2 is rational, 2 equals pq. Since 2 equals pq, we can square both sides of the equation to get 2 equals p squared, q squared. Multiplying both sides by q squared, we obtain 2q squared equals p squared. This tells us that p squared is an even number since it is equal to twice q squared. Now, let's consider p. Since p squared is even, p must also be even, as the square of an odd number is always odd. Thus p is even, p equals 2k. Substituting p equals 2k into our equation 2q squared equals p squared, we get 2q squared equals 2k2 equals 4k squared. Dividing both sides by 2, we have q squared equals 2k squared. This implies that q squared is also even since it is equal to twice k squared. Now, let's consider q. Since q squared is even, q must also be even. Thus, q is even, q equals 2 meters. We have now established that both p and q are even, contradicting our initial assumption that 2 equals pq is in its simplest form with p and q being coprimed since we have found a common factor of 2. Therefore, our assumption that 2 is rational leads to a contradiction. Hence, we can conclude that 2 is irrational, and it cannot be expressed as a ratio of two integers. The method of infinite descent enables us to use this contradiction strategy to prove the irrationality of certain numbers, such as the square root of 2. By assuming the rationality of 2 and deducing that it leads to a contradiction, we have shown that 2 is indeed irrational. The method of infinite descent provides a powerful tool for establishing the properties of numbers and equations by systematically contradicting assumptions. It allows us to delve deeper into the nature of mathematics and uncover intriguing truths. And that's the method of infinite descent in action. By employing it in our proof of the irrationality of 2, we have demonstrated its effectiveness in reaching profound conclusions. I hope this video has shed light on this remarkable method and its application to number theory. Thank you for watching.